Mic good? Okay. All right, hopefully you were in the right spot. It's the perfect place to be after lunch. So we're going to introduce ourselves in a minute, but you are here for practical techniques, gathering and managing your system requirements. Oh, can I have the clicker? Forgot to grab it. Thank you. So my name is Becky Linton, if you don't know me. I'm a certified LabVIEW architect and the LabVIEW champion. I am a senior systems engineer and an engineering team lead for Conrad Technologies. And no, I did not change companies. Conrad Technologies purchased BI Engineering last year, so last fall. So since January 1st, essentially, we are now Conrad Technologies USA. So I am based out of the Detroit, Michigan office. And I'm going to talk a little bit about upfront about requirements, and then I'm going to turn it over to Jarobit.
Yeah. So.
Oh, grab that mic.
So. Do you hear me now? Yeah, okay. So I'm Jarobit Pina. I'm the IoT line manager for my company and also the team leader for the NI technologies. I work in unambiguous solutions, and our field of expertise is safety and mission critical applications. So we also need to do quite a lot of work with the requirements.
All right, so a quick agenda for what we're going to cover today. I'm going to start out with the first half. We're going to talk about why requirements, why they're important, just a little bit of background on them. We're going to look at the definitions for requirements for IEEE and INCODES. We're also going to do a quick back and forth on good and bad requirements. So that's a test for you guys. So you have to pay attention up front, because halfway through we got a quick test, okay? And then I'm going to turn it over to Jarobit for the managing requirements and traceability. So a quick quote here. I like to start out with a quote. And before I even read it, I want to have my little brag moment. Do you see that picture? I took it. I got to go to the Great Wall of China last fall, so my whole family went on vacation to Japan and Asia. And if you know me, I'm a huge Disney fan, and this was the ultimate end to my Disney stuff because I've now been to every Disney theme park in the world. Very exciting for me.
Life goals.
Life goals. That is major life goals for me. So, all right, it is not enough to do your best. You must know what to do and then do your best. So if your project doesn't have requirements, you don't know what you're doing, right? So let's move on. Real quick, I want to start with the comic. When a user takes a photo, the app should check whether they're in a national park. Oh, sure, that's easy. Give me a few hours. Oh, wait, and check whether the photo is of a bird. Now I'll need a research team in 5 years. So knowing fully up front what you need to do can totally change the outcome of your project. Not only which team members you bring on board, but also how long and how much money you should charge. So why are they so important? It's the foundation for every successful project. It is a way to separate your wants from your needs, and it can help prevent scope creep. One thing I hear a lot from people is, well, my customer gave me requirements, I'm good. That's not really true. Your customer might have requirements that they wrote, but there's usually a lot of extra information in there. So your customer requirements are not the system requirements for which you are building your test system. A lot of times they give you the actual product specifications of the thing you're testing. That is useful information, you need that information, but that is not the system requirements. The other thing that customers like to put in there is a lot of design constraints, and we'll talk about those a little bit later, but that's not a true requirement. And then sometimes there's extraneous information that oh, it has to be, so many users, or extra things that aren't really hard requirements, but nice to haves. So those might be the wants versus the needs. So you should always write your own system requirements document. This is extremely important. It helps you get a better understanding of what you think your customer is asking for. Because if you write down the requirements of what you think you're building and you give it back to the customer, it gives them a chance to actually take a look at it and be like, whoa, you were way off base here. This is not what I was asking for when I gave you my requirements. So it opens up a dialogue between you and your customers. One other thing, your system requirements is not exactly the same as a system specification. So there's lots of acronyms in engineering. You'll see SYRS type documents or SYR. You'll see software requirements, hardware requirements. There's a ton of different things. This is kind of more of an IEEE definition, but you have typically a higher level system specification. Now, in this case, your system could be a test system, or it could be, if I'm an engineer designing a test, an actual product that I'm selling to somebody, it could be that type of specification. There's certain requirements it has to meet, and a lot of times that gets broken up into deeper and deeper levels. You'll have hardware and software. Under hardware, you might break it up into communication layers. In communication layers, you might have CAN, and then under CAN, you might have CAN open versus high-speed CAN, and so forth. Something that your system specification contains, that's a little bit different, is it can contain the design constraints or any extraneous information that you want to put in there. So this is more of a top-level document versus the actual requirements that need traceability. So requirements can and will change. This was said on the keynote stage a number of times this week, so I was kind of proud that they said that. That's just life. That's going to happen. You have to deal with it. Now, change is not the enemy. Uncontrolled and unmanaged changes. So Jarobit's going to spend some time at the end talking about how to manage that. But I just want to mention that up front because I'm talking about requirements. I'm going to talk about how to define them. And unfortunately for you, you don't get to write them once. You get to probably write them 20 times because as the project progresses, your requirements change. You have to go back and revisit your requirements. It's not a document that you just finish and put to the side. It's a living, breathing document. So let's look at a couple definitions for requirements. Let's start with IEEE. So for IEEE, requirements should be correct, unambiguous, complete, consistent, ranked, verifiable, modifiable, and traceable. I'm not going to go into all of these in detail, but I do want to talk a little bit more about these three. Complete, unambiguous, and verifiable. So a lot of people up front say, well, I can't write my requirements because my customer is co-designing this product that I'm designing the test system for. So we don't know limits. We don't know certain things at this. It's like all to be determined that we don't know. So sometimes you cannot escape this, and that's okay. You can put a TBD, which is to be determined, or TBR, you'll see sometimes be resolved. And that's okay, but if it cannot be avoided, make sure these questions are answered. Why is the answer not known? When do you expect to have an answer by? And the key to me is, who is responsible for this TBD? Is it you or is it your customer? Because if it falls on you, don't forget about it. Put it on your to-do list to look into every week. Are we at a point where I can eliminate this TBD? Next, this goes into unambiguous. So IEEE likes to be very specific about the language of requirements. So if you've ever seen these documents, you might see this definition of shall, should, will, and may. And so shalls are the what to do. These are the things that need verified. And we're going to talk about that in a second. But shalls need verified. Shoulds can imply how to do something. Wills are a purpose, factor, intention. And may is a permissible action. And I have some examples later on. So this is something that came up last year when I was talking about requirements. Is what's the difference between validation and verification? Because requirements need to be verified, I said, right? I didn't say validated, I said verified. And so one of these answers the question, did we build the system right? The other answers the question, did we build the right system? Those are two different, very important questions. So let's look at an example. I thought this might be a good example because it's lunchtime. So I came up with a requirement, and I want someone to bake a sweet, single-serving dessert with a hint of chocolate for me. I think you each have one in your lunchbox. Looks good, right? So I'm like, you know what? They're talking about a cookie. I know they're talking about a cookie, chocolate chip cookie. So I can say, is it sweet? How could I test that out?
Bite it.
Bite it, right? That's a testable thing. Is it single serving? Some might disagree. I guess it depends on the size of the cookie. I prefer 2 or 3, but one might work for certain people. Is it a dessert? I think most people would agree it is a dessert. Does it have a hint of chocolate? Again, this is an arguable moment because some people might think a hint of chocolate is a chocolate chip cookie, but most people would probably agree that's a hint of chocolate. So what have I just done? Was that verification or validation? That was verification. I verified that I met those requirements. It's sweet, single serving, dessert, hint of chocolate. Yep, I met the requirements. Unfortunately for me, when I delivered my cookie to you guys, you were like, that's not what I wanted. I wanted a vanilla cupcake with chocolate frosting. How could we have prevented this? Any ideas? So we talked the requirements. I talked to my customer. Do you ever just deliver a system to them? Do you do something else first? What do you give them early on after requirements?
Prototype.
Prototype's a good example. What else? What else could I have done? Just a picture. I could have been a 3D CAD model of my cookie. I could have showed them that. Look how awesome my cookie is. Is this what you want? And ask them that. That's validation. So a little bit more about this. This is kind of a standard V diagram. You have requirements, design, development, and then I'm going to spend a little bit of time on validation and verification in the distance and how they're kind of tied together. But the key on this that I want to present is you should always plan your verification while you are writing your requirements. Because as you're writing a requirement, you need to think to yourself, can I test this somehow? Can I prove that I can do whatever I'm saying I can do in the requirement? One last thing to note, you don't go through that V diagram one time. You're going through this lots and lots of times. Every time the requirement changes, you need to rethink about how do I verify this, right? I like this slide because it shows different verification and validation methods. So the left oval over here is kind of meant to be verification. On the right-hand side is validation, and you'll see there's some overlap in the middle. And the dashed line oval is test, kind of how test comes into play. So if we look at how do I verify something, I can verify something by demonstration. The customer asks for a user interface where a user logs in. I can verify that by demonstrating that there is a user interface on the computer, a user login prompts up, and they typed it in, right? That would be a demonstration. I could also unit test my code that I wrote that the user's logging in, because maybe that requirement had a little bit more detail, like it pulls from a Microsoft account or something in the background on the computer, and that's how the login works. So that would be a way to test the verification. On the right-hand side, for validation, those are things like prototypes, like you mentioned, or a 3D CAD model. If we're just talking software and we're not delivering any hardware, we could look at UML diagrams. Is this how you expect the software to behave and operate? Is this what you're looking for? When all's said and done, you do need to do both. You don't get to just skip validation or verification. For a happy customer, you want both. So when the project's done, you need to make sure that all of your iterations, you've validated and verified that this is what the customer wants and that the system does what you told them to. So did we build the system right? Which one's that? Verification. Did we build the right system? Validation. All right, so let's move on to requirements definition for INCOs. So this is something Jarobit actually brought up that I knew nothing about, and so I've been investigating a little bit more because I find it super interesting. So how many in here are familiar with INCOs? Oh, yay, I learned something. I'm not the only one who didn't know anything about it. Okay, I feel better now. So this is the International Council of Systems Engineering. And if you go to their website, I was surprised to find they have kind of a vibrant office in Detroit. Like, how was I missing this? How are none of the alliance partners in Michigan aware of this or involved? So this is something I'm going to be looking into probably more over the next year or two. So they actually have a requirements working group. They develop a guide to write requirements. They kind of gather the best practices for their systems engineers that they work with. The key here is, though, they have biannual updates. When was the last time the IEEE requirement standard was updated? It was a while ago, wasn't it? Okay, requirements don't often change too much. So INCOs compared to IEEE, if we're looking at it there, the key here is it's not a standard. So some industries that you work with, especially regulated industries, may require you to do something like IEEE requirements type writing. Others might not care, and you can use what you want. The key here that I like is it's updated more frequently, and it's also focused on systems, whereas if you really dig down into and read the verbology like of the whole IEEE statement, it's mostly focused on software. So the interesting thing is, if you look at what they say a requirement statement should be, they're very similar. They should be necessary, appropriate, unambiguous, complete, singular, feasible, verifiable, correct, and conforming. What's also interesting is these are requirement statements, but they also break it up into a set of requirements. And so like groups of requirements, so maybe like your hardware requirements versus your software requirements. And these sets should be complete, consistent, feasible, comprehensible, and able to be validated. They also have a kind of a set of requirements writing rules, similar to the wording and so forth of IEEE. They should be precise, concretion, no ambiguity, singularity, completeness, realism, conditions, uniqueness, abstraction, quantifiers, tolerance, uniformity of language, quantifications, and modularity. And I have two examples here we're going to look at. So here's an example. The operation logger shall record any warning messages produced by the system. Don't read the stuff in the brackets there. What's bad about that? Any, right? It's very ambiguous. It's like any is kind of like a red flag. What's that any? So they improved it to make it acceptable by saying the operation logger shall record each warning message produced by the system. The other thing I pointed out in yellow there is warning messages is kind of a generic thing. Warning underscore message, when I look at that, I figure that must be some variable name or something in my software. That's a very specific term, right? So this is a much better requirement, the second one. So we have another one. Here's an unacceptable one. The control system shall close valves A and B within 5 seconds of the temperature exceeding 95 degrees Celsius and within 2 seconds of each other. Wow, that's a lot to figure out, right? If I'm looking at that, I might have to read that 3 or 4 times because it's kind of like, wait, so temperature has to exceed that, but it has to be within 2 seconds. That's 5 seconds. So how can I make this clear? So the one thing I want to point out in the red there is valves A and B. That's great, but what happens when my system expands and I have valve C, right? So a better way to do this would be to use the input valves. And maybe you define input valves in a table in your requirements. So that way, if you have multiple requirements regarding the input valves, you don't have to find all 20 requirements about your input valves if they're all the same, and you can just update your table to add, oh, now we have input valve C as well. So I wanted to point that out. The second one is, you have the whole within 5 seconds, within 2 seconds. Would a timing diagram be easier to read? Probably, right? Some sort of table or something to make it clearer to the user what you were trying to do. Because how I interpret that top sentence compared to somebody else might be totally different. And if you have a table or like some sort of diagram that shows this is where I'm doing this is where I'm doing it, like kind of like a flow chart, people are more apt to understand it. And that's okay. You can put diagrams and tables in requirements. It doesn't have to be just words. So this is the test. Are you guys ready? Good versus bad requirements. Starting out simple. Well, maybe not. The system shall wait 3 seconds. Give me a hands up if your thumbs up. Hands up if your thumbs up. Anybody like this one? Nobody? Okay. Well, guess what? You guys are right. This is not verifiable. How on earth are you going to verify that you waited basically 3.00000 seconds, right? That is an extremely hard thing to prove. Not only like if I'm doing it by hand with like using my iPhone as like a timer, but try doing it on a computer, right? To get it exactly 3.00 seconds. So whenever you're talking numbers, it's a good idea to give yourself a little bit of leeway, plus or minus. The point's probably there, right? Something, especially in real time, might be mission critical. It might need to be 100 milliseconds. And you might need to figure out a way to do that. But for the most part, when you're looking at things like this, waiting 3 seconds versus 3.1 seconds is not going to crash the system. Next, the system shall, oh, I cheated. The system shall read the UUT serial number from a barcode. I like this one because it's pretty generic. So some people are like, well, you should be more specific. You should say, is it a 2D barcode? Is it a 3D barcode? You know, and I'm like, well, that might change. Does it really matter? What's the point? What's the real key thing that the customer wants? They want somebody to come off with a barcode reader, scan the barcode on the UUT, and have it go into the system. So this is the simplest wording I can do to do that. Yes?
For the previous one,
Mm-hmm.
yeah, the system shall wait 3 seconds. Surely the system is also very...
Yes, the system is also very vague. That's something to watch out for is system, because are you talking your software? Are you talking a certain module in your software? So you need to be a little bit more specific, but this is kind of my cheap, generic, easy way. But that is a very good point. The system is kind of way too generic. I think I use the system for all of them because I'm lazy. All right.
One of them is consistency, I think, on the thing.
That's
so
true.
is it consistent?
I'm consistent, which is important. So set the power supply to 5 volts, 10 volts, 20 volts, and ensure the power supply actually is outputting the specified value. So here's how they tell you to do those steps. The test software shall set the power supply to 5 volts. We shall measure analog input 1. It shall fail if analog input 1 is less than 5 volts, and it will repeat the previous steps for 5 volts, 10 volts, and 20 volts. There's a lot wrong with this. Let's see if you guys, did anyone actually think this was good? I'd be really upset if you did. Okay, so anything wrong with this? Anyone want to point something out?
It's too specific, like the analog input 1.
Analog input 1 is kind of generic, but that might be my channel name.
Yeah,
So
okay.
It doesn't anywhere say turn the power on or turn it off or what's the
doesn't say
starting
turn it on or
condition.
off. So it shall fail if AI1 is less than 5 volts. So if I read 1,000 volts, am I going to pass? That's not good. That is definitely not what the customer wants. I've just blown up my entire system. But I passed my test. I verified it. The other thing is the will. So this goes back to the IEEE of the shall, should, will, may. So the test software will, so I actually don't need to verify that because I said will. But realistically, the customer really does want to prove that if I set my power supply at that and read it back, that that's what I'm getting. The other thing here is like the less than 5 volts, that's another spot where you should probably do 5 volts plus or minus a certain point. The test system shall contain a PXI 4070 for voltage measurements. Anyone for good? Got a couple goods maybe? Seems okay? Ooh, by the time we actually move forward, and I discontinued this module. That never happens, right? Never. So this is more of a design constraint. Something like this can go into your system specification document, because maybe your customer really loves that PXI 4070. We all know we have our favorite NI equipment and we want to use it. But you shouldn't really make that a hard requirement, right? Because things change, projects change. And I don't know about you guys, but we've been building like the same system for one of our customers for about 6 years now. There's been a lot of obsolescence in the old stuff that we've had to replace. Luckily we had hardware abstraction layers and things like that. But nonetheless, the core hardware that's going into the system has actually changed. So calling it out like that in the requirements can kind of shoot you in the foot. Because now you got to go change it when you're doing a duplicate system 5 years down the road. The test software shall be written in LabVIEW 2018. Good? Bad?
I guess it's bad for the same reason.
Right.
Bad for the same reason, but there's also another one. Can you verify this? Is anyone, like, if you deliver your customer an executable without digging through and just seeing, like, you ever notice sometimes you don't get just, like, the LabVIEW runtime engine for the LabVIEW executable version you put on there? I don't really know what version or how to tell without having, like, to write special code to see what runtime engine it's calling, what version of LabVIEW. Is it really worth it to prove that I wrote it in a certain version of LabVIEW? And so again, that is a design constraint. So with that, I'm going to turn it over here. You're going to take that one? Okay. Jarobit's going to tell us about managing requirements and tracing them.
All right, so before I start, I have a pretty strong accent. I'm from Spain, so if you don't understand anything, just let me know and I will stop and repeat. Okay, yeah, thank you. So, Becky, thank you. You gave us very nice tips to understand how we need to write the requirements and how to explain what we want to do with the customer requirements. But now we need to deal with that. We need to actually manage those requirements to see, to control the change, to understand how they evolve. And behind that, there is a whole engineering specialization that is telling us how to deal with all these changes and all the requirements evolution, right? And to understand this, let me talk about some bullet points that are defining the requirement management. By the way, is any of you writing the requirements? Is any of you dealing with requirements in their day jobs? Right. Okay. So we are good here. Right. So first, before we start dealing with the requirements, we need to gather all of them. And even though the customer thinks that it's a very nice and easy tool, I tell you I want my system to go to the moon, and that's it. You have all my requirements. We need to dig into them. We need to find out what exactly is he telling us. It's a very tough job. It's not easy. We need to ask him, how do we do this? Or what are the constraints? Or so it's a very long process that we need to document to go back and understand what the customer was asking us to do. But not only that, we need to archive all these requirements to be able to see how they evolve and tell to our customer, look, this is what we started defining, and this is where we are now. Are we going in the right direction? Are we taking the right decisions? And this allows us as developers and the customers to achieve a commitment between the stakeholders of the project. And having this commitment, we all know what is the goal. We all know where we need to go. We all know what we have to do when we are working, right? But not only that, we cannot freeze the requirements forever. We cannot say, the first thing you told me is what I'm going to do, and this is not going to change. We need to understand that the requirements are going to change, And the requirement management is a process that tells us how to deal with these changes. Implies to set some rules to analyze the impact of these requirements and understand and evaluate if they have to be changed or it's going to be a really tough job to do and it doesn't make sense because it's not critical, right? So having a good requirement management process, we will have an implementation of an effective change management, right? That is going to help us with that. Okay. Right. Okay. You may think now that manage the requirement is a good idea, but now how do we do that? What tools do we use, or do we use any tool? And some of you may think, all right, I only need to write them down. I'll be able to go back and check them. So how many of you are using these kind of tools to manage the requirements? Excel, PDF, Word? Right. They are a solution, also they are a bit outdated, and I'm going to explain why, right? Let me give you an example. So let's say that you are identifying all the requirements with unique IDs. And one day you are writing one of them, or you need to remove one of them, and you are called for a meeting, and you forget that you removed the requirement. Then you go back, and you need to start writing new requirements, and you use this last number, like the one you removed. Then you go to your code, or you create a new artifact that is referring to the number or the ID that you declared and then you remove. Now you have two artifacts in your system complying with the same ID but doing a different requirement. So controlling the system and the requirements with these tools can be a very tedious task and also prone to error. But not only that, we have more reasons not to abuse of these kind of tools to manage the requirements. On the one hand, what do we do when we write new versions of the requirement document? We need to add a change management tool. So we are adding a new tool to the equation. And also, what happens if two people are writing on the same document of requirements, on the same kind of requirement, and they commit these changes, but they forget to update before? We are starting to have data losses, so the consistency is not ensured, right? Now, it's very difficult as well to find out who is doing changes in the document, when they are done, and what are we changing, right? Using tools like PDF, that is pretty difficult. So this is a reason to keep the logs manually, and we are adding a new task to the requirement management process, and it's starting to be very, very difficult to keep, right? So that is one of the reasons why we start to think, right, is this making sense? Do I need to trace all the requirements? Do I need to work with them, or is it too hard, right? And not to mention, right, that we cannot trace easily all the requirements to our artifacts. So what we think is good is to use proper requirement tools, like Doors, Polarion, Llama, and some of you probably Jira, which is not a requirement tool though, but it's very useful, and we don't recommend it, but it's okay though. It's better than the document software, right? Is any of you using these tools? Right? There are many. So probably you'll see something in the end that you will like.
How many are Jira?
How many are using Jira? Or
Redmine is the same.
well, Redmine is the same, yeah.
Can you expand on why it's not recommended?
Not recommended because Jira is a task management tool. It's not like a requirement management tool. Although there is a guide from Atlassian to understand how you deal with requirements management. They say that it's not the tool intended for that.
For a small company that is not going to be having, like Polarion has a section for bug tracking, task tracking versus requirement.
Exactly.
But a smaller team is not going to be paying the
Yeah.
big work.
So that is also true, and that is why we say it's commonly used, but it might not be the best solution, right?
But it's Better than Word, so.
Exactly. It's better than any other, like any documentation support, right? Okay, and these are good because we have unique identifiers. We have one source of truth. They ensure that you are going to get a unique identifier always, right? We can improve the communication with our customers because they have a way to store all the comments on the requirement. They have also this capability of taking a snapshot of the requirements on a certain point, and then go later and compare how they were in the past, how they are now, and have a chat with our customer and say, well, look, you are changing all my specification always, and we cannot continue this way. Or say, well, we need to start thinking of, planning ahead. What are we going to do because the requirements are changing too much? So also they give us a native baseline. We can set attribute to the requirements and understand how they are right now. Like we can say it's a draft, it's open, it's finished, or different attributes, and we can understand what is the work we need to do on them, right? They have methods to understand who is changing the requirements, when are they changed, what is changed, which with other tools is practically impossible. And we can set a system administrator, and this system administrator can provide different privileges in the tool to our users. So in that way, probably like a common developer can change the status of the requirement without a revision. So things like those. Well, and apart from that, we can also have reporting. We can, other than the filters that we can add in STL, for example, if you are using STL, we can also filter by what are the requirements that are changing more often, which is not that easy in STL, right? So we can understand how our system is evolving and what are the parts of the system that are giving us more problems, right? And obviously, they have a native way to link to our artifacts and understand the traceability. So traceability, I have mentioned traceability many times now, but what is it? So it's a way to understand if a requirement is been finished, it's been done, or how it is, right? And it has a lot of benefits. On the one hand, we can analyze the impact of a change, right? When we are changing a requirement, we can understand how many artifacts of our system are going to be affected. How much is the work we are going to need to do for that, right? So they give us a coverage analysis. We have a link from our requirement management tool to our artifacts. We can understand how many requirements are done or how many requirements are left, right? And having that, we can also understand what is the project status. We can also know if we need a lot of work to do in this project or is almost finished, right? And if that is not enough, we can structure our requirements and the artifacts in different packages. So if we are required to comply with a requirement in another project, we can just take that package and take it there, which is easy. Is actually promoting the reuse of the code if we talk about software, and that is a good practice. So persistent relationships. This is one of the most difficult tasks for me to understand when I read about it, and is that I don't know if it happens in your company, but it happens in mine. Sometimes the hardest parts of our developments are in the head of one person, and they are difficult to get. It's difficult to get this person to share the knowledge. But if you have a requirement linked to that knowledge, and you have the different links to the artifacts, you can also understand what is what you need to do to be able to replicate this work. So you are sharing this knowledge by linking your requirement to the different artifacts of the system, right? And finally, test optimization. It looks like all right, I have a big system, and now I test everything when I create something new. But sometimes the test takes too long, and you cannot test everything. So by having the requirement traceability, you can set the minimum number of tests to be able to have like a decent coverage. I'm almost sure that it's going to work, right? Are you happy with that? Okay. Right. So maybe.
You would know if I'm not.
Yeah, I know. So, all right, tracing requirements might be a good idea, and you want to do it. So, what are the tools that we have in LabVIEW? Unfortunately, the only tool we have is Requirement Gateway. How many of you are using Requirement Gateway? 2, 3. Any feedback? 4? Any feedback other than this?
Old.
It's old.
Buggy.
Yeah,
Well,
okay.
It takes time to define new styles, new document types.
Yeah.
By definition, it also only works with, you're also doing add-on things like a Python or something else. It's
Mhm.
useless.
No, you can use it in other, as long as you have text, because you define the document type as text. And
It's
you have to
more
use regular.
Yeah,
It's not
Right.
done for you, it's more work.
Yeah, it is. This is what I was saying. Is the difficulty there is you have to create your own,
Yeah.
which sounds like work.
Yeah, exactly. Work you're not going to get paid for, you're not going to get anything onto the benefit.
Yeah, so we are not really happy with the tool, are we? and the reasons are clear. I mean, it was a very nice tool when it started, but it was years ago, and the technology are evolving. So what happens? We have an additional tool that we need to understand, and that is not cool, because we have an IDE, and we want to integrate everything in the IDE. We want LabVIEW to be more like up to date. We want LabVIEW to be like a good engineering tool, which is actually a good engineering tool, but we want to integrate more things in the IDE, right? And it's difficult to maintain because it's another tool, right? We need to go and add new features and add new linkage and APIs to the different tools that we want to link. And the worst is that it creates intermediate copies. So you change something in LabVIEW, you need to refresh the requirement gateway. You change something in the tool, you need to refresh the requirement gateway. So it's error prone, actually. And well, the tools that is linking, I just said, they are outdated.
Well,
Right.
there's the other thing that there's the cost of the license. So sometimes you end up with teams where only one person has it and everyone else has to type the covers. So you end up with covers that are not recognized by
Yeah.
the.
Okay.
the
That is another thing, right? So what we propose is to use an standard, an industry standard, right? And it's called the Open Services for Lifecycle Collaboration, or OSLC. This standard is defining the way the engineering tools should exchange data between each other. And more than data, more specifically, it's not data what they promote to interchange or to exchange. It's structured specific links, right? And that is good because you have now a link to the data and you don't have the actual data, right? OSLC is divided in different environments, like requirements, like architecture, others. And these domains are setting the capabilities that the tool must comply to be able to link the tool to the other tools, the other engineering tools, right? And also the ground principle, as I said, is that you are not changing the data. You are having links, so the data is always up to date, right? Okay, so if we see an example of the capabilities of the OSLC standard, and if we focus on rational doors, which might be the one that has more tools linked, we can see that we can have links to many different tools, like, for example, lifecycle management tool, here, like source code control tools, like issue trackers. We have also, what is it? should be Jira here. So the amount of tools that we can link by using this standard is quite big, right? It's not the same as just the requirement gateway. It's opening the whole world. It's giving us a way to link to different tools. So regarding to requirements, we think that if we had this layer implemented in LabVIEW, we could link any of the tools that are good for that, such as for Arion or Doors or Llama, but also Jira if you are a small company, and that'd be good because we are having a standard. We know that we are going to be able to have more tools, and it's not the new, and you can also integrate this in the IDE, right? So the benefits of having this layer implemented is not just that we can link multiple tools. It's also that we won't have intermediate copies anymore. You don't need to refresh a new tool. You don't have a new tool to maintain. It's just a layer that you put there, or you program there if you want, and you need to tweak it for the different tools. But it's a small tweak. It's not like create a new API, right? You have a wider range of requirement management tools to link, and also others. It's possible to be integrated in the IDE. You don't need to learn a new tool to be able to link your requirements or your tasks. And also, you have the potential to integrate other different tools for the lifecycle management, right? So at Tulma, we decided to do a proof of concept and see what it's able to do for us. We just linked IBM Rational Doors, right? But we could have linked any other, even documents like Excel. And the purpose of this is to demonstrate the potential of the solution and gather feedback from the community to understand if we need to go any further or not, if it's something that people like, right? And instead of giving you any more details, I'm going to go and play a video. Right. So let's imagine that we have multiple projects open and we want to link a requirements module. We can go there, check what is the project that we are going to link to the module, add the module, and the module is added, right? From now on, the project is going to be able to see the requirements of that module. We can select another one, and now we have two modules linked to the requirement, to the project. Now, if we go to our code, right? We open the block diagram, and we want to link one of our BIs to an existing requirement. We can just link the requirement, select the module. We have doors there, so we can check what is the requirement we want to link, finalize. This is not the nicest way to refresh, but we are finding a better way now. And you have the link. So you have the new requirement link to your code, and also you will see the tag, right? You will see the label. So your requirement is there, is linked to that BI, and you can see a label. Okay, what if we want to create a new requirement from our block diagram, right? We select add a new requirement, doors opens, we can choose create a requirement, and then we write what we want to create, the requirement that we want to create. So requirement for the DQ BI, right? Finalize and then refresh, and the requirement is created. And this is created in the tool as well. So it's everywhere. And then again, it's labeled, so we can see that the requirement has been created and it's been linked to the BI. Right, but let's imagine that we are not very structured right in our code. That we are a bit of newbies in LabVIEW and we do a spaghetti code. So we want to link a set of BIs or nodes to our requirement. We can choose like a group of items and say link requirement. From now on, we give you the ability to name that as a component. so virtual component for us, and link the requirement. And we will label one of the items. Right, you can see there how the requirement is done, and we will label one of the items with the ID and saying that it's a virtual component, right?
Is there a reason why the requirement number is not taken into the label?
Yes, because we didn't have the time to do that yet. It's a proof. It's a proof of concept.
Okay.
As you will see that there is no way now to identify the chain of the requirement. If you change the requirement in the tool, it won't tell you that in the code. But it's something we can do. But honestly, the amount of time we can invest in this is not justifiable if we are not going anywhere, if no one is interested. So we are trying to display the power of the adapter.
He's
and then-
teasing us enough, so we can tell him, please, please, please. do it."
Exactly. That is the idea. Right, so now if we go to the tool, like doors in this case, we will be able to see that our requirements are linked to an artifact, and we can see where the link is coming from, right? That is the link. And we can see that for all the 3 requirements that we did. There you have. No one. Right? And the last one. Well, this is okay, but we may want to visualize our requirements from LabVIEW. We may want to see how many requirements are we linking to our code. So we can go to the IDE, select view requirements, and we will see all the VIs or artifacts that we have linked to requirements. We can choose the requirement and see our summary. But not only that, if you have a virtual component, as the one we have now, you can see all the different items that are part of the virtual component, right? And then the same, you can go and see the summary. And from here, you can delete a link. So I'm going to delete this link to this requirement, so it's not going to be there anymore. You delete it here, it disappears in the tool. Right? It's not there anymore. Something that is nice to have as well is a requirements matrix, traceability matrix. And there you have. We can see all the VIs that are, or all the different items that are linked to requirements and how they are complying with each other. And finally, if we go to the tool, well, coming from a different project, we can go to the tool, configure the tool to look at the project, to look at the different VIs that it has. And from the tool, we can say, I want to link this requirement to this item in the VI. And it will create the link. So this is the power of the OSLC layer, or the OSLC adapter. And I think it's a nice solution if you are dealing with requirements. But anyway, it's always good to have feedback from the community, so we look forward to listen to your thoughts. And I leave Becky the microphone and give us a summary of what we have seen.
So real quick, I wanted to cover a few things. You want to give me the clicker there quick?
Yep.
Thank you. They're good. All right, this is very important, everyone. Ready? Every project should use requirements. The amount of detail in your requirements can be project specific. Obviously, if I'm designing something for the FDA, it's going to be a lot more detailed than if I'm building a small heated cooled seat tester for a tier 3 automotive supplier, right? It depends. What is the customer willing to pay for, and how much time up front? The other thing to think about is requirements can be a good way. If your customer is not willing to pay for it, have a junior engineer start learning how to write requirements. Have them come into meetings, have them write things, have you review them. Because just having an extra set of ears and eyes listening in on a project is kind of surprising. Because they might pick up something that you didn't even realize the customer wanted. There is something wrong with this statement though. Be aware of your language. Every project shall use requirements, all right? Just watch it. Write your test plan or your verification while you're writing requirements. This will save you a lot of time in the end. No one wants to get to the end of a project, have to reopen their requirements to figure out how to prove that they've met the requirements. You don't want to wait that long. That's too long. And I'm not talking writing a detailed test plan of open this, measure this, remove this wire, do that. It doesn't need to be that detailed, but you at least need to have some sort of summary stating that this section of requirements I'm going to verify by demonstrating. This section I'm going to verify by manually using a digital multimeter, removing some wires. Just simple statements like that so that even the customer has an idea of how you're going to prove it out. We actually share that documentation with our customers because sometimes they're like, whoa, you guys are going way overboard. Or, hey, I think you don't have enough detail in here. You need to verify this a little better for me. And remember, verification and validation are different. Both important, but different. Select a proper requirements management tool. Jarobit talked about a number of them. We still use Word. It's not my favorite. But we have so much invested in Requirements Gateway at this point that it's going to be difficult without another COTS tool or something we could purchase that will probably be stuck in Microsoft Word for a few more years, I'm hoping not, but that might happen. But the one thing I want to point out here that Jarobit kind of said too is, if you are not writing requirements, even writing them down in Notepad is better than using one of the fancy tools, okay? Write them down. You need to have requirements. Traceability is recommended and sometimes required. It can help you out because, like Jarobit said, if you're doing traceability on your project, you can easily see, wow, we've only met 50% of my requirements and we're delivering next week. That's not good, right? Or maybe you're like way ahead. We've got 95% of the way there and we still have a couple weeks left. So it's things like that that you need to keep an eye on, and traceability can help with. And finally, this is something that a lot of people, and this comes into the JIRA conversation kind of, is issue tracking is not the same as requirements tracking and tracing. As you're doing development, you're going to find issues, you're going to find bugs, you're going to find features you want to add. Those are issues. You do need to track those. You do need to assign an engineer to fix or do that. That is not the same at all as requirement tracking and tracing. Requirement tracking and tracing goes back to your original requirements document for your customer, right? So keep that in mind, that those are two different things. And JIRA was really more of a tool developed for this, not that. So people can use it, and they do use it for that. And like Jarobit said, there's like a document out there or something?
Yeah,
like
there's a link.
A link to tell you how to do it. But again, it's not the best way. But that's still better than nothing, and probably better than Word or PDF or Excel. So any questions?
I guess, Becky, from moving from requirements gateway to a tool like this, the part on LabVIEW would be scripting, right?
Mm-hmm.
Just go
So in order to make it work in NXG, we need scripting.
Yeah.
It's only been said a few times this week. I think.
Yeah, we just need to repeat it, right? Because
over and over again.
we would be able to take the cover stack and change them to use the OSLC format.
Or someone at NI could use that OSLC layer,
Yeah.
develop a .NET version plugin for NXG or LabVIEW or anything, and give it to us as part of the product. That would be fantastic.
Yeah. We can only dream.
We can dream, yes. How many NI people do we have in here? We got a couple. All right, you guys taking that feedback, right? Okay. Question?
At the beginning of the project, so you get the project requirement document, which is everything, like everything for everybody. It's like 3 or 4 different suppliers. So then you can take out the bit that's relevant to you. Do you create another document, or do you put that straight into the?
I would create my own document. So the question was, if you're coming in on a big project and you're one of maybe like multiple suppliers, let's say there's 3 suppliers, and the customer gives you their giant document of this is what you're building, this is what you're doing, but I'm only doing a small part of it. Do I need to create a second document or another document? And yes, because that's the one that's important. Because the key that'll help is that'll spark the discussion between you and the customer then that this is the part I'm doing, this is all I'm doing, is it enough? Am I doing too much? They usually won't tell you that, but that could come up. So having that other document, it seems like an extra layer of work because the customer's going to probably change their document, bring it back to you, but that's the living and breathing requirements document that you need to live on. You need to be responsible for yours. And plus, if you are using Requirements Gateway or something like that, where you have to like define styles and things, having to try to take their requirement document and make it fit into your styles is not easy. Starting with your template, with your styles, and putting your wording in makes it easier. And I think with your tool, it doesn't matter as much, but it's still. Any other questions?
So if you're using a tool like you showed us, how do you handle code reuse? If I'm using same test for multiple programs that have their own unique requirements, how do you handle double linking it?
Oh, that is something to explore actually. That is a good question.
Repeat the
Repeat the
question.
question.
All right, yeah. So the question is, if you are using a tool like the one we are using, how do you handle the code reuse? I guess that we can have a remove of the link, all the links like action, and then remove everything that is linked to doors, and that will be simple enough.
But could you create a requirements document just for the reusable
Yes.
code? And then
Could.
you have to then create an intermediate document that says, this requirement here covers the requirement of these other documents.
Well, that actually goes in line with what we mentioned in the requirements traceability, like package all the requirements that are linked to a certain reusable requirement, actually. And then go and take it to any other project. So that is another way to solve it.
So the suggestions like, yeah, a user login module, right? That would have its own requirements document that you reference in your project requirements document, and those are just static. I like that idea.
I like it. I don't know.
Well, that's why you invite me to this thing.
We're so lucky to have Fabian with us.
Yeah, I think you just keep turning up.
Any other questions?
Yeah.
Beck?
Will it be possible to write your own plugins to target different requirements tools?
So the question was, will it be possible to write your own plugins to target different requirements to? And you can probably answer that better with the OSLC later.
Yeah. I mean, it's not like a plugin. It's a layer that you program on your tool. So it's a standard layer, and it's supposed to link to different tools. But the thing is that you need to tweak it a bit. So you don't need the plugin actually. If you comply with the standard, you will be able to connect to the different tools. But every tool or every manufacturer understands the standard in his way. So there is a little tweaking to do.
So the requirements are not really clear then.
Yeah.
But it's better than nothing.
Exactly.
Someone created this. Yeah, and if you go to the website, I looked it up at one point. There's a lot of information on the standard. And basically, Doors had to implement that OSLC layer in their stuff. And that's what Jarobit's talking about is they might have read that requirement slightly different than how Jira or whoever else implemented it within their software.
So what we
you
did
may-
is to implement the layer there on the ID.
So that's why you can't create one layer and have it work for all tools. That'd be ideal, but
Yeah.
but I think the point is you can reuse a good chunk of it.
Mhm.
Any other questions? All right, well, thank you guys.
Thank you.
Don't forget the survey thing.